Hello and welcome to this Reigate Maths video on the first year content of the Decision 1 unit for the A-Level Further Maths for Edexcel. My name is Simon, and in this video we're going to be looking at the first of two sorting algorithms that you have to know for this A-Level unit, this one being the bubble sort. Now both sorting algorithms do, as their names suggest, sort a list of numbers or a list of letters into some order, usually either ascending or descending order. They do them both in different ways, and one is significantly quicker than the other, and that you'll see in the next video called the quicksort algorithm. The bubble sort algorithm is not a particularly good algorithm from a computing sense, other than that it's very easy to do. It's very greedy, and it's very particular in the way it works. So let's have a look. We're going to take a list of numbers and we're going to put them in ascending order. So the list of numbers we're going to look at is 7, 2, 6, 4, 5, 8, 3, 1. So what I'm going to do initially is show you what's happening on the first pass, or what happens in each pass. And then over here on the right, I'm going to write down what we actually do in terms of in an exam and what we need to write down. So what we do in our first pass is we take our list of numbers and we bubble the first two elements. So do not do this, what I'm doing here on the right, on the left, when you actually answer these questions. This is just demonstrating what's going on, and to some extent why it's called the bubble sort, because we form a bubble. This is an example of what's known as an exchange sort algorithm, and there are tons of those. We don't need to worry about them for the A-levels, so if you're interested, you can go and look them up. So in our bubble, we compare these two numbers, and we put these two numbers specifically in order. So we're putting them in ascending order, so we want the smaller one on the left. So now we bubble up the second and third elements, and we repeat the process. So 6 is smaller than 7. And we keep going. So this is very arduous to do, which is why you don't write this down unless you are explicitly told to. But hopefully you can see what I mean by it's relatively simple to do, as long as you pay attention at every step and don't write down the wrong thing. So we keep going, and we can see at this point here, in each of the bubbles that we've done so far, we've swapped the numbers over. So in terms of there's some terminology. When we bubble two numbers together, this is known as a comparison, because we compare two numbers together. Very simple. And when we, like we've done for each of the passes so far, we have swapped the numbers over. So we have done 1, 2, 3, 4 comparisons so far and 4 swaps. Here, we are doing a fifth comparison, but because 7 is smaller than 8, we don't swap the numbers over. So we don't have a swap here. So we've got a number of comparisons. We've got 5 comparisons, but only 4 swaps so far. We're nearly finished with this first pass. So we compare the 8 and the 3. We swap those over. Oops. Just write that a bit neater. Something that's really useful with doing both the bubble sort and the quick sort, which we'll cover in the next video, is keeping your columns consistent. You can see here I've tried as best as I can to make sure, even when the numbers don't match in the rows, the columns are nicely sorted. You know, we've got a nice grid system here. It just makes it easier to follow what's going on, and it makes it easier to not misread a number. Okay, so in this pass we have made 1, 2, 3, 4, 5, 6, 7 comparisons. And 1, 2, 3, 4 we didn't there, 5, 6 swaps. Now there's a useful thing to pay attention to about the number of comparisons. We can see we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. And in our first pass, we had 7 comparisons. There's always n-1 comparisons in our first pass. Now, the good thing here is now we know that this number 8 is fixed. This is in the right place. So when we do our subsequent passes, we don't need to look at 8. We know it's in the right place already, so we stop there. So that's going to have implications on the number of comparisons we make on each subsequent pass. Now, in terms of in the exam, or generally when you're doing this algorithm, you don't do this, what we've just done here. This was a demonstration of what is going on. What you would actually write is just this final list. Okay, so 2, 6, 4, 5, 7, 3, 1, and then the 8. Okay, I'm going to list the number of comparisons and the number of swaps as we go, just because sometimes that's quite useful to have, but not always. And that's our first pass done. Now in our second pass, we're going to do exactly the same thing, but we're going to ignore this 8. So we can see, we compare the 2 and the 6. The 2 stays where it is. That's one comparison. We compare the 6 and the 4. They swap over. So one comparison, one swap. We compare the 6 and the 5. They swap over. 3 comparisons, 2 swaps. 1, 2, 3. We then compare the 6 and the 7. We put the 6 down because the 6 is smaller, and we pick up the 7. We compare the 7 and the 3. We swap them over. We compare the 7 and the 1. We swap them over. Now, we don't compare the 7 with the 8 because we know the 8 is in the right position. So we just put the 7 down and the 8 is already there. So we've made 6 comparisons. We made 1, 2, 3, 4, 5, 6 comparisons. And then we made no swap there, 1, 2, and then 3, 4 swaps. So you may already be starting to see a pattern with the number of comparisons on each pass. The way we stop the bubble sort algorithm is when you do a pass that has no swaps in it. So I'm going to do a few more passes and we'll get to that point. So you can see here I've done the first 6 passes. And we're nearly at the right position. But I wanted to make a point about these last 2 passes because this is where students typically needlessly lose marks. So we can see here the 3, 4, 5, 6, 7, 8 are all in the right positions. Okay, we now just compare the 1 and the 2. So we've made 1 comparison and 1 swap. The thing with the bubble sort is that you stop once you have done no swaps. So we have done a swap on this last pass. So we can't actually stop there. So a good kind of very simple rule of thumb with bubble sort is once you've got the list in order, just write it out again. Okay, we didn't make any comparisons because we were only thinking about the one, and we made no swaps. But this is the important thing, that we have made a pass with no swaps in. So this took us 8 passes. So hopefully you can see that we had 8 numbers. The maximum number of passes that you're going to have to do is n. So the maximum number of passes you're ever going to have to do for a bubble sort algorithm is the same number as the number of numbers. If it's a huge list, so if it's like 10, 12 numbers, you're not going to do 10 or 12 passes. They're not going to get you to do that. Now, we can see here that this is the sequence n-1, n-1, n-2, and so on, down to 2, 1. So the maximum number of comparisons is going to be n-1 plus n-2 plus and so on, down to +2 plus 1. Using our summation formulae for the sum of natural numbers, this comes out as the formula 1/2 n n-1. And we're going to come back to this later, because this gives us something called the order of the algorithm comes from this formula. That's the bubble sort. It's very simple to do. It just takes quite a long time, and you've got to write a lot out. You might not have to do all of these passes. If you ever get a pass that has no swaps in it, you stop. Okay, so again, once you've got the list in order, write it out again. Don't do this with the bubbles unless you're told to. That is just a demonstration of what is going on. This is more likely, this side is more likely what you're going to be writing down in the exam. In the next video, we're going to be looking at the second sorting algorithm, which is a little bit more complicated, but it is quicker, hence the name quick sort algorithm. But that's the bubble sort algorithm. Thank you for watching.